Welcome, Chief. Good to see you.
Good evening, Jeff Deering, Fire Chief, here tonight to speak to Article 17, fund the construction of a new fire rescue station, and how important that the role of the fire rescue department plays in protecting the lives and property of the citizens and visitors of our community. We know, we've established over the years that our current station is outdated with major deficiencies. At the time it was built in 1987, it was built for 15. Our current staff is 33 full-time equivalents. The interior layout slows our response time. This is an ongoing challenge of the current facility. And importantly, the health and safety of our staff is in peril with improper decontamination and lack of separation of spaces and the ongoing air quality issues. The current station, as it was built, was built in 1987. At the time it was constructed, there were 2 members on duty. Shortly after the building was occupied, it went to 3 members on duty. And at the time, the fire department moved from the police station at the corner of Eldridge Parkway. They had 3 bays and 2 rooms, so it was an improvement at the time. During the design of the current fire station, 5,000 square feet was cut from the design of that building in a cost-cutting measure, resulting in a smaller building. In 1987, gender spaces were not a thing in fire stations. They were added later by the members of the department. The current building is just under 11,000 square feet and is plagued with ongoing issues including air quality, mold, rodents, roof leaks, recurring plumbing and electrical problems. We have an ongoing lack of space for staff, training, and our equipment. You'll see in some of the photos, the layout of the building makes it hard for it to operate. We don't have a proper decontamination area, which is in the bottom right. That's what a makeshift area that we've constructed over the last couple of years. Furthermore, there's a fitness area that is really important to the health and safety of our staff that is in the middle of the apparatus bay. The ladder truck actually backs into that workout area. It's the same area where firefighters are coming back and forth from calls. In the bottom right, or excuse me, bottom left photo, that's the public lobby of the fire station. It's also where several hundred people every year come in with a medical emergency. So you could walk in to get a permit and there's someone having chest pain at the same time in front of you. Those are just a few of the challenges. So what has brought us to the point of needing a new fire station? Importantly, the changes in the mission of the fire department over the years has provided a need that is different than it was in 1987. The types of work that your firefighters do on a daily basis has changed drastically in nearly 40 years. Furthermore, the health and safety of firefighters, the concerns of that have become real. We didn't know those things in 1987 when the station was built. There isn't a proper separation of living quarters from the apparatus and the hazardous equipment. We don't have the decontamination areas. We don't have modern ventilation. And that puts our firefighters, your firefighters, at risk for long-term health issues. It's important to note that firefighters nationally have a 9% higher risk of being diagnosed with cancer and a 14% higher risk of dying from cancer. These are things that we need to engineer into our buildings to make it safer for our staff. Additionally, response times and operational readiness are affected by the current layout of the building. We just can't get out of that building fast enough because of the layout of it, and that affects response time. Additionally, the station doesn't meet modern building codes or accessibility standards. They really weren't a thing in 1987, but the building is not ADA compliant. It doesn't meet the structural rules for major storms or natural disasters, when that building would be most vulnerable and most necessary. Another thing that has affected that building is staffing. When the station was built, there were 2 members on duty. We're now currently at 7. We've had to make those changes over the years because the fire service has changed. In that 1987 to 2025 period, we've seen a steady increase in the calls that we respond to, from about 800 in 1987 to 2,866 in calendar year 2025. We've also seen the staffing increase from about 12 full-time equivalents to 33. So we're still doing the same work with more people in a small space. Over the last few years, we've had multiple independent studies and assessments that have confirmed what the community already knows. The current station is functionally obsolete. We need a new facility that protects our staff and ultimately protects the community going forward. So what have we done? We've done a lot. The station was built in 1987, but since 2019, the town has engaged in a number of studies and plans to look at what the needs are of the station. Going back to 2019 was when the first feasibility study was started for that. An HVAC study, the strategic plan, the staffing study that was done. All of those spoke to the needs and the challenges of the current building. In 2021, there was another fire station feasibility study, and as part of that, as a break off to that, there was a location study done that showed us through data that the 58 Eldridge Parkway area is the most ideal location for a fire station here in Orleans based on response time. 2025 campus study, again, looked at the uses and where we could site a station on there. 2025, the voters were gracious enough to approve the design funding that has brought us to where we are today, as well as in November 2025, the article that purchased the 56 Eldridge Parkway property, the advanced dental property that was transformational to the siting and location of the new station. And here we are, coming up on Maytown meeting, looking for the potential to construct a new station. I think it's important to recognize the ongoing deficiencies of that station. Again, the health and safety of the staff, how those health and safety issues affect our service delivery to the public. Even just the driveway alone is that emergency vehicles are mixing with civilian vehicles, and the potential for an accident there is real every single day. Questions I get a lot. Chief, how did we get to this program? How did we get to this floor plan? Well, looking back through those various studies, we have worked with the various consultants over the years to look at what are the needs of that station, what are the smart things that we should have as part of it, what is the potential needs right now and in the very near future, and then work with the consultants to design those spaces. We're very cognizant of how big those spaces are, but what the needs are. And we're trying to be very smart about designing a building that's appropriate for the service that we provide. We want to have space to put the equipment in. We're at the point right now where we're designing apparatus around the building, not designing apparatus to serve the community. We also have required training needs that we can't meet in the current facility. We just can't do them. We don't have the spaces. The design that we're working with right now, still very much being refined, looks at what the current and future needs are of the fire department over the lifespan of that building, hopefully 50 years plus. Very hard to predict 40 years ago when they built the fire station what it would look like today, but I bet they would do it a little different. And we've also learned from the mistakes of our neighbors that many of the fire stations that have been built, and other municipal projects, but specifically fire stations, are built for the fire department in the time they're in, at the time they occupy it. And as soon as they move in, it's too small, or something changes, and now they're trying to capture space that they don't have. We want to be smart about that. We want to be very careful. We take that very seriously as far as, let's build a station that's appropriate for what that fire department's going to look like in the now and in the immediate future. We've done that consulting with our neighbors. We've done that consulting with the different architects and designers that have been involved in the project. We look at national and local trends to gather that information and make smart decisions on that. I think it's also important to recognize the location, again, is important. This building is built around response time. What the fire department does is respond to emergencies as quickly as possible. Location is important. How fast can we get out of the building from the time we get a call to the time of a fire truck or an ambulance is on the way, but also how fast we can get to whatever location we need to go to in Orleans. And we know through the different studies that have been done that from the 58 Eldridge Parkway location, we can get to 99.6% of the properties in Orleans in 8 minutes or less, which is in line with national standards for response time. And that's a very important piece. You just can't put a fire station just anywhere. It has to be in the right spot. Ultimately, this project is critical to the public safety and to the fire and rescue operations. A new fire station will help us ensure the health and well-being of our firefighters and protect them from the hazards of their occupation. Our community invests a lot in these people to provide a very important service. We want to make sure that they're healthy to deliver it now and into the future. We need to remove the obstacles of a slow response time. A new layout of the building will help do that. We must ensure that the training and readiness of firefighters is there to respond to emergencies by having the appropriate training facilities to meet the required training that we can't currently meet. We want to protect our vehicles and equipment from the weather and make sure it's ready to respond. The salt air, the winters here are very harsh on our equipment. Much of it is parked outside, and that affects the long-term investment on those vehicles. Ultimately, by having a new fire rescue station, it maintains the quality of life that we all enjoy in this community, whether it's the firefighters providing towards that quality of life or the citizens enjoying it. At this point in time, I'm going to turn it over to Ted Galante to talk a little bit more about where we are right now with the project.
Thank you, Chief.
Ted, thank you. I'm not sure about the computer.
And as we're switching technologies, I want to thank the Chief. And as he mentioned, the process that has gone through most recently has involved so many folks. Thanks to the Fire Rescue Building Committee, some members are here today, but I know in speaking to the Chief, he has shared plans that have been developed with the assistance of the architect with all his members for input. So this is really, really a team effort, and one that I know the Select Board is really appreciative of. Ted, we got an update from the Building Committee Chair last meeting. Thank you, David, for that, and we're certainly looking forward to your presentation today. And I would just say, hopefully, some of the comments you heard, and I took a long list of those that we heard at public comment, you may be able to address in your presentation.
Good evening, Mr. Chairman, Board, Town Administrator. I'm just waiting for the screen to show up. Fantastic, thank you. Okay, good evening. I'm going to go over a number of things. I have a lot of slides. I talk quickly, and I'll try and be thorough. But after presentation, welcome questions. I have to turn this on, I suppose. So we're just going to go over quickly the feasibility study that was done in 2021, search for the new site that was done in 2022, the campus plan analysis in 25, some of the existing site conditions, discussion about net zero. We're going to review the building plans, the conceptual plans where they stand now, the conceptual massing, the schedule, and the cost. So I'll go through those things rather quickly. In 2021, we were asked to do a study, and I understand that there are studies that were done before we were involved, of the existing fire rescue station. We came out and did a thorough analysis of the building and fundamentally wrote an executive summary. I won't go through all the slides, that there is so many problems with this building that Chief Daring just talked about, and many more. There's only so much we can cover in these presentations, that it really is time for the building to be replaced. There's many deficiencies. I won't go through all of these, but here are some of the site deficiencies on the outside of the building. There are many on the inside of the building. But one of the things that the Chief mentioned that we take very seriously, firefighters are some of the most generous people that, they run into burning buildings, they drive 2 car accidents, and they take care of all of us when something goes wrong. They are subject to exposure in various ways, in contaminants, carcinogens, that their PPE, their personal protective equipment, is supposed to cover. This slide shows some of that. A lot of that PPE goes back to the firehouse. Sometimes it goes home. And one of the big concerns for us is absolutely the firefighters, but the firefighters' children. We don't want any of this PPE contaminating their car, contaminating their personal vehicles, getting anywhere near their house. It needs to be decontaminated at the fire station. And that's a big part of what we focus on, decontamination. There's an NFPA standard that talks about hot zones, transition zones, and cold zones. The current building is fundamentally a hot zone. The fact that there's a fitness room on the apparatus bay is hurting our firefighters and possibly hurting their families. We can't have that, right? The red components are the hot zone, the green are the healthy zone, the cold zone, and there should be a yellow transition zone between them. We divide it up architecturally and with a mechanical system. This building does not have that. As you can see, the building is too tight. There's pathways for carcinogens to get from the apparatus floor to the other parts of the building, and people are, what happens when we work out, right? We breathe heavy, we inhale a lot. Well, if we're doing that on an apparatus floor where there are carcinogens, that is totally unacceptable, and I think that's something that we all need to focus on. Turnout gear, it needs to be cleaned and stored properly in a decontamination room with proper extractors and washers and dryers. It's not to be stored on the apparatus bay where it is here. It's not to be exposed to sunlight because UV damages it, which potentially puts the firefighters at risk. So designing a clean fire station, designing a building that protects our firefighters also protects their families and the community, and that's essential. And that's one of the key findings of the 2021 study. In 2022, the town hired another consultant, KBA, with Mitchell Associates. Bob Mitchell and I speak nationally at fire station conferences. We've been doing it for 20 years. And they recommended, it was a site study, they recommended this location, 46 Eldred Parkway, as they've called it, as the best location in town for the fire station. So independently of our firm, another firm that's one of our competitors, but we work with nationally, recommended this, and we agree with that. 2025, my colleague Tina Tanyos and I did an analysis, a master plan, as it were, for this entire property, for the elementary school, for the fire station, for a community building, and to reimagine this part of the land. Out of that came many things, the possibility of a future elementary school, the green blocks on the left, the possibility of a future recreation facility, the blue building, moving around some fields, but also a new fire station. And the new fire station, what I'll point out is at the bottom of the slide are the two dental offices here, and the new fire station is set back here beyond the existing fire station. The floor plan, interestingly enough, looking back at some of the earlier studies that our competitors did, is the same size, right? They're looking at the same size building. This program has been a question and a need for the Orleans Fire Rescue Department for many, many years. 2026, we are now where we start. We look at the existing property. The town made the very wise decision to purchase the dental office and to purchase additional land nearby. We start to look at that facility and understand how maintaining the existing facility for use by the fire department allows us to build another building adjacent so that services can be delivered, and saving a lot of money not having to build another facility, a temporary facility elsewhere. And so we can go through this. These are quick. We're cutting this section in half, cutting the site in half. One of the complexities of the site are all the dips in the land. We've studied that extensively. We've studied where we might locate the building on the site, whether it's a 3-story building or a 2-story building. We did a very thorough analysis. At this point in the discussion, we were sharing a driveway with OES. That has since advanced where we're not doing that any longer. There's a bunch of phasing diagrams. Ken, you would appreciate these, and you'd probably be able to give us some great feedback. But there's a bunch of phasing diagrams where we talk about how the construction can happen and keep the fire department up and operational currently in order to develop the site and then eventually take down the fire station and operate out of the new building. Out of that study, extensive research and analysis and cost, it was established that a 2-story building is the most cost-effective rather than a 3-story building. Leveling the site is part of that. We've had geotechnical borings done, which for those who don't know that term, it's about you drill holes in the ground and you assess the quality of the soil. I'm happy to report, we just got the preliminary report 2 days ago. The soil is very suitable to standard spread footings without any complexities of deep footings. There are some soil we have to cart away, not too much, but we're in a good spot with geotech. And so that's a really important finding for the cost of a building and how we develop a building. We've studied if we can develop the building and keep the existing facility long-term. We think that that's not a feasible option. We think it's going to be an expensive option, and it's going to primarily, it's going to force us to not hit net zero, which is another big piece of the puzzle, and it would add a lot of cost and complexity to the project. We are landing on a site plan that now takes OES access road out of the discussion. We have an access road in where the existing access road is. We have an access road out around the other side, preventing the concerns that the chief rightfully has and his team rightfully have about having one access road and an incident happening on that access road, and then people not being able to get in and out, and the fire not be able to deliver their services. We have apparatus, excuse me, we have apparatus coming out of the front of the building, the major apparatus, and we have the minor apparatus coming out of the rear of the building. We've been able to, through a lot of iteration and gyration, we have Eldridge Parkway is clearly the front of house now, and so we can now have an entrance to the front of the building. Someone can come in, they can go into the front of the building. A visitor can come in, go into the front of the building, go get their blood pressure taken outside of public view. They have privacy, and the fire department can operate as they need to operate. A call can come in, they can deploy safely out as they need to, etc. The site gets leveled out. We're doing it in a way where we can not build a retaining wall. We're trying to navigate placement on the site. Again, the acquisition of that 0.48 acres really is a wise approach from the town because it allows some latitude in how we put this facility together, and that's working out very well. Okay, let me take a breath. Net zero. Net zero is employing renewable energy sources on site to offset all energy used on site, right? So regenerate energy on site and use that to power the facility. That's the goal of net zero. There are many more complex components to net zero, and we have the what I would say is the Commonwealth of Massachusetts guru on the call for questions and answers later, Chris Schaffner from the Green Engineer. He's been a fantastic consultant of ours and was on Deval Patrick's Sustainable Energy Resource Development way back in the day, and has been working with us, and he can speak much more thoroughly to this. I won't go into it too much, but Chris and I and others are just finishing up the Cambridge main headquarters building, where we are drilling 22 geothermal wells and putting solar panels, photovoltaic panels, to make this a net zero building. So that project is in process, and we'll know more very soon because the building is about to be finished. In Exeter, New Hampshire, a town that we never thought would opt for net zero, actually on town floor, mandated that the building become net zero and didn't increase the budget. But we have 127 kilowatt of generation on that building. In Chelmsford, Massachusetts, they actually just received $1 million grant from I forget the exact group. It's a state grant for geo and solar panels. So we're putting them on those facilities. In Belmont, we just finished a unrelated building. Those are all fire station public safety buildings I just showed you. In Belmont, we just finished a new ice rink, an ice hockey rink. For anybody who knows Belmont's hockey rink, they sorely needed this. But we have 23,000 square feet of solar panels on there, generating a fair amount of energy. So this is the trend, and this is the way things are moving and the way we think we can take the Orleans project. What we're starting to consider in this schematic design phase that we're in, this is a plan showing some array of photovoltaic panels on the roof, right? Where the south is here, so we have good sun exposure, and possibly augmenting this with a solar canopy in the back. The size, configuration of those things is still in discussion, but that's one of the approaches that we're taking. These circles represent geothermal wells. Again, early on, we need to do an energy model, and we need to sort out exactly how many geo wells. But given our experience, given our team's experience, we think we know the numbers now, and we can get us there. We just need to do a little more study to really nail this. The discussion about sewer and or septic. I can just assure all of you that the building committee has been fastidious about asking questions, driving points, and trying to think long-term about this facility, where the septic gets placed, if it's going to be connected to sewer, if there's a system where we can plan for the sewer if the town doesn't get it here fast enough. There's a forward-looking building committee that is thinking 5 chiefs down the road. That's a boon for the town. That's a really wonderful thing for the town. Building plans, really quickly. The red areas are the hot zone, right? That's the dirty area of a fire station. The yellow areas are the transition zones. We put buffers. Those are buffers between the red and the green, right? The green is the firefighter's second home. We want them to live there healthy. We want their contaminated equipment to stay in the hot zone. We decontaminate the firefighter in the hot zone. We could decontaminate their equipment. There are paths of travel where they come back from an incident, they put their gear in the extractor to clean it, they go into a shower, they clean themselves, then they go into the living quarters. And so there's a specific path of travel to make sure that those firefighters are kept healthy. The building that you're in currently does not have anything like that and cannot be configured to have that. This would be a fantastic ad for the fire department for long term. In terms of building size and quality and caliber, again, at conferences twice a year, we speak on these things. Chief Daring is a fantastic chief. I'm interested in the 5 chiefs from now and how this building will work for them. That's what we're trying to do, is always look forward so that you don't repeat the 1987 problems. And that's one of the reasons we're keeping it as a low-lying building for ease of access for firefighters from the living quarters into their apparatus and deploy very easily and quickly. So it's about making it as effective and efficient as possible. Right now, we have 4 conceptual massing diagrams that we're going to show you, some quick renders. Nothing has been settled and solidified, but I'll go through them quickly. We have one that we call the net zero version, simply because it has flat roofs, and we showed you the solar panels on top, and I feel comfortable with the quantity of solar panels we're able to put on this building to get us closer to net zero. Again, we have to do the calculations. Just quick diagram. The building, the mass on the right is where all of the apparatus would be. The mass on the left is where the offices and residents will be. And so we're starting to consider treating them slightly differently. There's the transitional version. The slide just changed, and there's a peaked roof shown on the residential and office component and the flat roof on the fire station. There's a training tower in the back. I should have mentioned that. Chief Daring talked about not having training. One of the things that we do is we build training into the building, right? The fire apparatus floor needs very high ceilings. The supporting rooms need low ceilings. We use a mezzanine above those low rooms to provide training. We put in manhole covers so that when a utility worker is stuck in a manhole and needs to rescue, guess who's going to come get them? We want to train them properly, and they can go through that manhole cover. So the elements like that built into using the space efficiently, the volume of the space efficiently, for that to happen. That was a little sidebar. So you got the net zero, we got the transitional version, we have a clear story version to try and bring sunlight in some way, and we have the 2 gables version, right? So we have these 4 versions that we're thinking about, and fundamentally all the other elements stay the same. The floor plan stays the same, the site plan stays the same. We're really just thinking about the mass of the building here and what that might mean. Ken raises many good points about budget and funding and components. One of the things that would affect the funding and the budget of this project is the massing, right? It's clear. It's not only the size of the construction, but how do we condition that space? Where sprinklers are needed, et cetera. So without talking specific numbers, If I just went through this quickly, net zero, we think is $1 sign. Transitional is $2 signs. Clear Story, maybe $3 signs, and Two Gables, $4 signs, right? Just like when you choose a restaurant on Google, is it a $30 restaurant, or is it a $50 restaurant? That's the kind of picture we're just trying to paint right now, right? We are in the schematic design phase. It is taking longer as a phase, primarily because there's been a lot of acquisition and land and discussion, and I think the town is making great decisions, and so I don't mind it taking longer. We quickly want to finish this phase right after town meeting so we can go into design development, spend the rest of the year putting all the documents together, the construction documents. There's a lot of work by a lot of engineers, by a lot of smart people that go into this. We work with the building committee throughout the whole process, with the community and community meetings throughout the process, so that we can get to a construction period. And we believe the construction is 14 to 16 months. Construction costs only go up. So if this process takes longer, the construction costs go up. So when we're putting together a budget, you'll see on the next slide, I believe, that there is an escalation, and that escalation is to a certain point in the midpoint of construction. If we move that midpoint of construction into 2028, we end up with a higher escalation. So we want to manage that as we're rolling along. Well, you can't really see this slide. This is a budget that I imagine I can zoom in, but we do. Let's go back here. Yeah, there's a number of pieces that go into this budget. Fundamentally, they are something known as hard costs and soft costs. And at some point, I'll learn how to use a computer. There we are.
There you go.
On the left-hand column, everything from this total estimated hard cost and up is the cost of construction. Those are the things that if you turn the building upside down, you can't shake them out, right? They're all the hard cost, what it costs, all the things that you can knock on. Our low end is 41 million. Our high end is 45 million. If we add an escalation to the midpoint of construction in December of 27, we're at 44 million and 48 million. Everything below that are soft costs, right? Those are the development costs. What it costs to pay the architects and engineers, what it costs to pay the project manager, geotechnical administration during the project, surveying, all of these components, FF&E consultant, a fire station alerting system, all of those components, and those add a fair amount to the project because they're necessary. They're all required components. Materials testing is for someone to come out and check the reinforcing steel is installed properly, et cetera. And so that's where the high end is the $60 million component, and the low end is the $53 million component, and that's kind of how we landed on there. But again, this is with very preliminary design and not full design. A decision needs to be made in order to advance to full design. To put it in context, in both Northbridge and Dennis in 2022, we finished buildings that were bidding and building at around $600 a square foot, hard cost only, construction cost only. We are now in a position where we are estimating and bidding at $850 a square foot. That is simply the cost of construction. The Ipswich is about to go to town meeting, and Chelmsford the bids came in on Friday. So these are hard numbers, actual numbers in place right now. And so everything we're doing in Orleans is in line with everything we've been doing. I guess that's the point. I'll stop.
Excellent. Thank you very much, Ted. And again, as you echoed, and I've watched or participated in the building committee meetings, they are excellent. I mean, looking around the table, the expertise that is brought to it, everything from concerns about the school. Our select board member is at the table as a voting member, keeping us informed. All the expertise is just really, as you know, asking excellent questions and always thinking ahead. So we're at a point of this being an update. Again, this was excellent, really. And I know, as was mentioned earlier, Ken mentioned it, you have been under the gun, pressed and moving. You have an incredible team that responds so well, and we really appreciate that.
Thank you.
But-
Thank you all for that. And
Yeah.
thank you, Ken, for that. We're delighted to be here.
Well-
We're really happy to be here. And our team, Tina and others, Russell and Paulo and Michael and others are doing fantastic work back at the office. So thank you for that.
Well, the other thing for folks that don't know, and Rick Pomeroy couldn't be with us, but he is our owner's project manager, hired to look out for the best interests of the town. Not that you are not doing it, but he also has a number of projects under his belt that really brings a lot of skill to the table, including, like you said, at the building committee meeting, this table of cost. He scrutinized every single line, so it gives us more confidence in terms of the experience that has been brought to it. So I'll be happy to open up to questions from the audience, but,
Still have Darren.
oh, Darren, sorry I didn't follow the menu. So Darren is going to update us on cost and potential taxpayer impacts, I understand?
Yes.
Good evening, Select Board. All right, let's see if we can get this up on the screen. Oops.
Nice, got it.
All right. So based on the budget that was just provided and the escalation that was discussed as well, tonight I'm going to provide some tax impact in terms of 60 million and even take it down a notch to a $50 million potential model to see what that impact would be to taxpayers. So based on the conversation we had a week or so ago about debt assumptions in terms of borrowing, this debt assumption would be that this borrowing would be a 30-year level debt. It'd be 4.5% borrowing rate. We're assuming we're starting with tax rate base starting point of for FY26 at the value that's shown there, $7,284,806,000. Current tax rate 6.11 per $1,000, and the median home value in FY26 of $1.15 million. We're also looking at a growth rate assumption of annualized 3.44 compound growth derived from our town 7% every 2-year valuation planning pattern. So that would be incorporated, which would project a median home value in 2031 up to $1.361 million, $1.362 million. So those are the planning assumptions. So if we were to borrow $60 million, the town approves this project at town meeting, we would place this on the 2031 debt schedule. The $60 million would translate to an increase for a median home value of $581.49 per year. So that is, and you'll see we have it broken out by essentially every value so anyone can look at it and see how it impacts their assessed value in terms of the increase that they would see in 2031 based on $60 million. Any questions on this? Okay. And if we were to take it down to $50 million, this is what it would look like. It'd be an increase of $484.57 for the median home value in 2031. So about $100 difference for a whole year, or about $8 or $9 a month difference if you're on your mortgage.
Million.
So, and you can see the spectrum there. So that's really it. I just wanted to show this to you so that you could see what the potential impact would be, and we've broken it out in terms of value spectrum across from 250,000 to 2,650,000.